Hi, Assalamualaikum and a very good morning. So we are still in chapter 1 matter, and now we're going to focus on the subtopic of 1.2 mole concept, part 4 of the video. So in previous video, you have seen about the same learning objective, which is to define and perform calculation for molarity and molality. So we have learned 1 and 2 in the previous video, which is in part 3. Into this video, we're going to focus on the balance, number 3, number 4, and number 5, which is mole fraction, percentage by mass, and percentage by volume. Okay, so without any further ado, let us start. So what is mole fraction? So mole fraction basically denoted by a letter X. So mole fraction is a ratio of the number of mole of one component to the total number of mole of all component present. So as what you can see here, the mole fraction of a component A is equal to the number of mole of A divided by the total number of all the component. Or you can put it as XA equal to NA over NT. And the mole fractions are independent of temperature. Dia tidak bergantung kepada suhu, and it has no unit because the units here up here is mole and the denominator is also mole. So mole and mole can be cancelled out, and as a result, they're going to be no unit. And the next information is that the total mole fraction in a mixture, which is in a solution, is always equal to 1. So you can say that if a solution consists of a component A, B, and C, hence, the mole fraction of XA plus XB plus XC is equal to 1. And the mole fraction of a component, okay, bagi satu component is always smaller than 1. So what is meant by this statement is that because you know that the summation of all component is equal to 1, you know that for each component, for a component, this value need to be lesser than 1. Okay, for example, I can say that XA is equal to 0.3. XB might be 0.5. XC might be 0.2. But the combination of the summation of XA plus XB and XC gonna equal to 1. Okay, so in order to understand more about this, let us look into the example. So for example number 1, what is the mole fraction of CuCl2 in a solution prepared by dissolving 0.3 mole of CuCl2 in 40 mole of water? So you can imagine that you have your CuCl2, which is 0.3 mole. And now you're going to dissolve your CuCl2 solute in 40 mole of water. So this one is your water, and you have 40 mole. Okay, so you need to find the mole fraction. So mole fraction is denoted by X. The mole fraction of what? The mole fraction of CuCl2. So you're going to put it as XCuCl2 equal to the number of mole of CuCl2 divided by the total number of mole of all component, in which the component here is CuCl2 and also water. So we can add up the number of mole of this one and the number of mole of this one as a total component. Okay, so the number of mole of CuCl2 is 0.3. Meanwhile, the total number of component is 0.3 plus 40. And hence, once we do the math, we're going to get 0.0074 without any unit because mole and mole going to be cancelled out. Now we're going to move on to the next question, which is example 2. So what is the mole fraction of CuSO4 prepared by dissolving 30 gram of CuSO4 in 200 gram of water? Okay, so we have our copper sulfate, which is 30 gram. And then we have our water, which is 200 gram. So we need to find the mole fraction of CuSO4. Okay, so in order to get the mole fraction, we need to find the number of mole first. Number of mole of CuSO4 and also the number of mole of water. Okay, so the mole of CuSO4 is basically mass, number of mole, mass divided by molar mass. So the mass of CuSO4 is 30 gram and the molar mass here is 160. So please calculate it one by one. 64 plus S is 32 and 4 atoms of oxygen multiplied by 16. Okay, so you're going to get 160. Okay, so the mole of CuSO4 going to be 0.1875 mole. And now the mole of water. So the mole of water, the same thing, mass divided by molar mass. So the mass of water is 200 gram. And then the molar mass of water is, you know that water is H2O. So 2 times 1 plus 16. So the molar mass is going to be 18. Okay, and hence the mole of water going to be 11.11111 mole. Okay, and we need to find the mole fraction of CuSO4. So CuSO4, we need to find the mole fraction of CuSO4. So you know that the mole of CuSO4 is 0.1875 and the total number of mole is 0.1875 plus 11.11. Okay, so once we do the maths, we're going to get 0.01659 without any unit. Okay, now let's say if I ask you another question, what is the number of mole? What is the mole fraction of water? Okay, this one is additional question. What is the number of mole of water? So there are two ways in order to do that. So as what I have shown in the earlier slide, we know that X is equal X CuSO4 plus X H2O is basically equal to 1. Okay, so the same formula as what you have seen in the earlier slide, which is XA plus XB is equal to 1. Okay, because we have only two components, right? So XA plus XB is equal to 1 lah. Okay, and since our mole fraction here is known, which is 0.01659 plus XH2O is equal to 1. So our XH2O 1 minus 0.01659. So when you plug in the calculator, what you're gonna get is 0.98341. Okay, so this is method number 1. You can use the expression here, or you can also use this method where you can use XH2O. Okay, so this one is second method, is equal to NH2O divided by NT. So NH2O, you know that is equal to 11.111 divided by the total number of mole here, which is 0.1875 plus 11.11. Okay, and you're supposed to get the same answer as here, which is 0.98341. Okay, so that's all for the mole fraction. Now we're going to look into the next part, which is the percentage by mass, percentage W over W. So percentage by mass is basically defined as the percentage of the mass of solute per mass of the solution. So the formula is given as the one in the box here. So the mass of solute divided by the mass of solution, and since we are talking about percentage, so we need to multiply by 100%. Okay, and as what you can see here, the unit is gram and gram. So basically it doesn't matter. It can also be kilogram and kilogram as long as the unit cancel out. Okay, and the percentage by mass is basically and usually used for a situation where the solids dissolve in a liquid. So you might remember a usual structure looking something like this. where a solute, when placed inside a solvent, for example water, the solute going to dissolve in the solvent in order to produce a solution. So this is where the application of percentage by mass is being used. And because of this relationship, we know that the mass of solvent plus the mass of solute going to produce the mass of the solution. So by understanding the expression here, we can use that in order to solve the percentage by mass problem. So to understand more about this, let us look into the next slide. So a sample of 0.892 gram of potassium chloride, KCl, is dissolved in 54.3 gram of water. So we have our KCl here, which is 0.892 gram. And now it is dissolved inside 54.3 gram of water. So they ask us, what is the percentage by mass of the solution? So you know that the percentage by mass is equal to percentage W over W equal to the mass of solute, which is 0.892, divided by the mass of solution. And you know that the mass of solution is basically mass of solute plus mass of solvent. So you need to add up 0.892 plus 54.3 gram. Okay, so the mass of solute is 0.892 and the mass of solution, we need to add up both of these together. And we need to multiply by 100%. Since the unit is gram and gram, so we can cancel out. And hence, when we do the maths, we're going to get 1.61%. Okay, now we move on to the next question, where example 2 here said that hydrochloric acid can be purchased as a solution of 37% HCl. What is the mass of the solution contains 7.5 gram of HCl? So the diagram is shown as here. So we need to find the mass of this solution. So 37% here refers to percentage by mass, percentage W over W. So you know that the formula here is percentage W over W equal to mass of solute, which is the HCl, divided by the mass of solution times 100%. So our percentage W over W is 37%, and the mass of solute is known, which is 7.5 gram, and we need to find out the mass of the solution. Okay, so we can bring the 100% to the left hand side first, so that it becomes 0.37, and we can bring the mass, or we can bring the mass of the solution on the left hand side, and 0.37 on the right hand side. So 7.5 divided by 0.37. So at last, the mass of solution, you're going to get 20.27 gram. Okay, let's say if I ask you what is the mass of solvent, how do you going to answer this? Okay, correct. So the mass of solution, okay, is basically equal to the mass of solute plus mass of solvent. Okay, so in order to find the mass of solvent, mass of the solution given here, which is 20.27, we need to minus with the mass of the solute, which is 7.5. Okay, so 20.7 minus 7.5, you will get 12.77 gram. Okay, now we're going to move on to the next representation of concentration, which is percentage by volume. So the same thing, percentage, but now we are going to focus on volume, V over V. So percentage by volume is defined as the percentage of volume of solute per volume of the solution. Okay, similar to before. Okay, so percentage W over W refers to the mass of solute per mass of solution. But since we're talking about V over V, it's going to be volume of solid divided by volume of solution. So the formula here, you just change it with volume and volume times 100%. However, there are going to be two situations here, and the most common one is these two. So if a solute is a solid, okay, so you can imagine it to be something like this. So if our solute here is a solid and it's dissolved in a solvent, you can say that the volume of the solution is equal to the volume of the solvent. Okay, misal kata letak garam, garam tu larut dalam air. So the volume isi padu air akan sama dengan isi padu solution. So there's not going to be changing much, and hence we can say that the volume of the solution is equal to volume of the solvent unless stated otherwise. Okay. Meanwhile, for the second situation, if a solute is a liquid, okay, so if two liquid mix together, you can say that the volume of the solution is equal to the volume of liquid A. For example, liquid A here is equal to plus with volume of liquid B, because when you add up together volume of A with volume of B, what you're going to produce is a new volume, which is 200 ml. So 50 ml plus 150 ml become 200 ml. Okay, for here, let's say if you have 5 gram of NaCl and this one is 100 ml of a solvent, roughly saying that the solution will also be 100 ml. The changes is very not much, so we can just assume it the volume of solution is equal to volume of solvent unless stated otherwise. Okay, so to understand more about this situation, let us do some question. So, for example, number 1, a 200 ml of unknown perfume contains 28 ml of alcohol. What is the percentage by volume of alcohol in this solution? So let's say if you have your alcohol bottle here, okay, so inside the perfume, it's gonna contain 20 ml of alcohol, okay, but usually we're gonna dilute it with some water, for example, okay, and it was dissolved up to 200 ml. So now we need to find the percentage by volume. So percentage by volume is equal to volume of solute, which is our alcohol, which is a liquid, divided by the volume of the solution. So the volume of solution is already given as 200 ml because it's sum up everything here. Okay, so the volume of solute is equal to 28 divided by 200 because the 200 refers to the solution straight away, times 100%. So at last you're gonna get 14%. Okay, as simple as that. Okay, and this one is just an extra information or application in real life. For example, if your perfume is 14%, you know that your perfume is eau de parfum in French. Okay, and this might be very expensive in comparison to eau de toilette because it only have very less percentage of alcohol, and eau de cologne is the most cheapest one because it has the least amount of alcohol. Okay, and this one, the perfume, will last longer, right? Now for the last example, which is example 2, we need to calculate the volume of antifreeze required to make 12 liter of a solution of antifreeze, which is 38% by volume. So the volume of antifreeze here refers to a volume of solute, and we need to make up until 12 liter. So this one is volume of solution. Okay, and 38% here because it refers to a percent, so you know that it refers to percentage, volume by volume. Okay, so you're gonna use this formula and you need to find the volume of solute. So basically you just plug in away which is the volume by volume, is 38%. The volume of solute, which is the antifreeze, is something that you want to find out, divided by volume of solution, which is 12 liter. Okay, so liter here also need to be in liter, and then times 100%. So now 100%, we're going to bring it to the left hand side, and we can multiply 0.3x times 12 in order to get the volume of antifreeze, which is 4.56 liter. Okay, so I think that's all for this video. See you again some other time. Bye.